Hey guys, this is question 7 from the second assignment. We're supposed to show like this, that if you look at R of A intersect B that's contained in R of A intersect R of B, and then give an example that shows that we can't replace this subset with equality. Okay, so we need to remember what are these symbols. So R is a binary relation, just a set of ordered pairs, and A and B are sets. So what does R of A mean? Well, that is just the elements B such that AB is in R for some A. Okay. So basically, the things that are paired with some element of A, call that R of A. Sure. Okay, so now let's do this question. This is pretty straightforward. Let A be an A intersect B. Or sorry, no. I guess it's not as straightforward as I thought. So let's let maybe C be in R of A intersect B. So what is the definition? Well, that means there exists an element of A intersect B. So there exists A and such that A and C are related. Oh yeah, so sorry, such that A and C are in R. Okay. Now we have to show that this element C is in R of A and also in R of B. But of course, A intersect B is contained in A. So A is in A since it's in A intersect B. So that implies that C is in R of A, as AC is in R. Similarly, A intersect B is also contained in B. So that implies that C is in R of B for the same reason. And that implies that C is in R of A intersect R of B. This shows that, so we've done it for arbitrary C, so now we can say that we get this containment. Okay, and that kind of completes this first part, and now we have to prove that we can't replace contained with equals. So let's try and come up with an example. Let's try and make up an example where R of A intersect B is the empty set, but R of A kind of intersects non-trivially with R of B. So let's see. We could make A intersect B be the empty set. That would be fine. There's a bunch of different ways to do that. So let's try. Maybe A is going to be like, let's just call it A. B is going to be called the singleton B, and A and B are going to be different or something. Okay, but my relation R is going to be two ordered pairs. Okay, so now A intersect B is the empty set, so R of A intersect B is the empty set. But what is R of A? That's the singleton C, which is also R of B, And since R of A equals R of B, that's the, there's also the intersection. So here we see that R of A intersect R of B is a singleton C, but R of the intersection is empty. Okay, that completes question 7. Of course, there's like many different examples for this. I tried to think of the simplest one that I could think of. Okay, so next video is going to be just a quick one about assignment 5. So see you then.